In this last video for the course, I want to recap all of the methods of hypothesis testing, the statistical approaches, and how to determine a statistical approach from a research question. Here is the recap of all the hypothesis testing we've done. For a single categorical variable with two categories, there is a percentage of the category that fits one of the two categories. This is a single proportion. The null hypothesis is usually a threshold value for the proportion. A normal distribution is used, and the test statistic is turned into a z-score, which is then made into the p-value. For two categorical variables with two categories each group from one of the variables has a proportion in the other variable. With two proportions, the sample statistic is a difference in the two proportions. The null hypothesis is usually setting that difference to 0. A normal distribution is used, and the test statistic is again turned into a z-score and then a p-value. For categorical variables with more than two categories, there will be more than two proportions. The test statistic here is a chi-squared statistic, which measures the total variation between all the categories. The null hypothesis is that there is no variance, and a chi-squared distribution is used for the sample distribution. The sample statistic is placed on the chi-squared distribution to create a p-value. For one numeric variable, there is a single mean. The null hypothesis here is again typically a threshold for this mean. A t-distribution is used instead of a normal distribution, and the sample statistic is given a t-score, which leads to a p-value. For one numeric variable measured in two categories, there will be a difference because there will be a mean from each category. The null hypothesis is typically that there is no difference between the two means. And again, a t-distribution is used, and a t-score is assigned to the sample statistic, which leads to a p-value. For multiple categories, all measuring a numeric variable, this means there are multiple means, one for each category. With more than two categories, we measure the total variance. The null hypothesis is typically that there is no variance among the categories. The test statistic is a complicated thing called an f-statistic, which measures the total variance in the sample, and this is given an f-score, which places it on an f distribution from which a p-value is calculated. Finally, for two numeric variables, we investigate the relationship between them. If we assume a linear relationship, then there is both a slope and an intercept. The null hypothesis is a value for this, typically 0 for the slope. A sample statistic is that slope, and a t-distribution is used for the possible slopes. A t-score is assigned to the sample statistic, from which again a p-value is calculated. That's a lot of stuff. Many tests, many distributions, many variables. The point of this video is to recap and to make sure we understand the connection between a research question and a statistical test. So we'll go through 3 research questions. Here, the researchers are testing a new treatment for high blood pressure. In the usual setup for a controlled trial, there is a control group and a treatment group. For both groups, blood pressure is measured. What is the statistic here? What is the test? Well, the measurement is numerical. Blood pressure is a number. Since this is numeric, the statistic is a mean, so we're dealing with means. But then there are two groups to compare, treatment and control. Each of those groups has a mean, so the comparison is a difference in mean. That's our approach here. This is a difference in means. The next example is about polling before an election. The preference in the poll is between 4 parties, and the poll is looking at 4 age categories. The researchers want to know the voting preference between the 4 options and compare those voting preferences between the 4 age categories. What is the statistic? And what is the test? Well, all the variables are categorical, so all that we have are proportions. What percentage of each age group votes for each party? There are 16 combinations here, 4 parties and 4 ages. And this is too much for a single comparison, so instead we want to measure the total variance between all 16 possibilities. Since we're dealing with proportions, that total variance is measured by a chi-squared test. Finally, there's a large data set on tree growth. It has many variables, including species, habitat, which has several set categories, height and circumference of mature trees. What is the statistic? What is the test? Well, there's not immediately one answer here. Many tests are possible. There are both categorical and numerical variables. So here are some of the possibilities. I could look at the heights of various species. If I am looking only at two species, well then I would get a difference in means, and I could use a t-test for such a difference. I could look at the heights and circumferences. These are both numeric variables. So maybe there's a linear relationship between them. I could test the linear regression of the sample, again using a t-test. And finally, I could look at the circumference of the trees, varying both by the species and the habitat categories. Each species and habitat pair would have its own mean, so I would be comparing many means. ANOVA is the process to do this, using f-statistics and f-scores to test whether or not there is substantial variance between the species and inhabitants, measuring the circumference of the mature trees.